So today I'm going to be presenting that mouthful of a paper title, but basically it's about assessing the impacts of the electronic logging device mandate in the trucking industry, which happened between 2017 and 2018. And we'll talk about what some of those terms mean here in just a moment. First of all, do apologize for dropping this novel on you. In my defense, there are a lot of pictures. Um, in my world, this is a short paper. Just to be clear, the other one I was eyeing was like 50 pages. I'm like, they're going to run me out of town on a rail. So before we dig into the paper itself, I want to go through some background here. So commercial truck drivers in the US, particularly long distance truck drivers, are paid piece rates. So that means that they're paid by the miles they drive most commonly, or by the load. And because of that, they've got this powerful economic incentive to work long hours. This is a pretty old data set, but you can see like 65 hours a week was the average. It goes far higher than that on the top end. And so because of this, the Department of Transportation and the Federal Motor Carrier Safety Administration heavily regulate the working hours of truck drivers. So these hours of service regulations state they can only drive 11 hours within a 14-hour window, after which they need a 10-hour break, along with a bunch of other kind of detailed issues with weekly limits, daily break requirements, things like that. And to ensure compliance with these regulations, they're required to track their driving hours. And since the 1930s, they've done so on a chart that looks about like this: paper logbooks. So they just kind of have a continuous line that moves between these four categories: off duty, sleeper berth, driving, and on duty, not driving. And the thing about these paper logbooks is they're easily falsifiable. Truckers have a lot of colorful terms for these things. They'll call them swindle sheets or comic books, things like that. And so if a law enforcement officer pulls them over and asks to check their logs, they're also required to provide supporting documentation like fuel sales receipts, things like that. But still, there's a lot of room and latitude to kind of chisel here and there to make the logbook look like it's in compliance, even if they may have driven much longer. So starting in the 1980s, we first had the development of kind of primitive electronic logging devices that are tied to the vehicle's engine and track if the vehicle's moving. And so that makes these records a lot less falsifiable. Adoption was slow, but by the 2000s and the 2010s, a lot of particularly the large companies had already adopted these ELDs. But starting in 2017 and 2018, DOT started requiring all interstate carriers to use these electronic logging devices. And that is what we're talking about today, is that mandate. So the ELD mandate was enforced in two stages. First, in December of 2017, there was the soft enforcement period, where initially drivers weren't fined or officially cited for not having an electronic logging device. They were just given informational citations. Hey, you're required to do this, do it. And then the mandate really started growing teeth by April 2018, where they started doing formal citations. Now, the researchers in this paper have data that cover all three periods here. They've got data prior to the ELD mandate, during the soft enforcement period, and during the hard enforcement period. And their big idea here is that something called offense displacement is going to occur. And this comes from criminology, and it essentially states that if you've got somebody who engages in illicit activity and you start heavily surveilling that particular activity, they may increase illicit activities in less surveilled areas. And so to put that more specifically here, in the paper, these are stated very much in economies. So I'm translating a bit here, but the three core hypotheses are that whenever we get the ELD mandate, that we will see reduced hours of service violations, but we'll see increased unsafe driving violations. And then finally, perhaps as a consequence of the increase in unsafe driving, we'll also see increased crash rates. So those are the core hypotheses that they're trying to test here. And to test this, they use data from the Federal Motor Carrier Safety Administration's Motor Carrier Management Information System, or MICMIS. This is regulatory data that all these interstate carriers have to submit to FMCSA. And it gives basically anytime a truck is inspected, we get a line in the data set, tracks violations, crashes, and it also has a carrier census that gives us some information about the business operations and fleet characteristics of these companies. And they get data from January 2017 through August 2018, so we're covering all three of those enforcement periods. It's important to note here that this isn't a sample. This is the whole population. This is everyone, right? So it's all federally registered for-hire interstate carriers. So let's talk about what that means. A federally registered interstate carrier is just any trucking company that transports stuff across state lines. This is as opposed to intrastate carriers who operate only within a single state, who may, but generally aren't required to register with Federal Motor Carrier Safety Administration and the Department of Transportation. For hire here means that they're hauling other people's stuff, right? So you don't have your Walmarts in here, right? Walmart is a registered interstate carrier, but they're a private carrier. They only haul Walmart's freight. But anyway, after filtering through those categories, they still end up with 4 million separate inspections, over 200,000 carriers covered, and about 150,000 crashes. So big pile of data. But it gets a bit complicated here because they want to conduct this natural experiment, but they don't have clean treatment and control groups because they can't actually observe which carriers are using ELDs prior to the mandate and which ones weren't. Because there were a lot of carriers who were using mandates before they were legally required to do so. But generally, this fell along kind of the size distribution. So the small carriers were really unlikely to have been using ELDs, and the big carriers were, on average, tending to use towards ELDs before the mandate. So by September 2017, which mind you is just a couple of months before the soft enforcement period began, only about 15% of small to mid-sized carriers had even started implementing ELDs. This isn't have ELDs, it's starting the implementation at all. So they carve up the set of carriers by size to generate a bunch of treatment groups, but their control group are 8 specific large asset-based carriers that were well known to be using ELDs before the mandate. And asset-based here just means that they own the trucks that they run, right? They're not leasing trucks, and they're also not just leasing trips from owner-operators, which is a whole other can of worms I'm not going to open here. But all of these are really big. They all have, believe they all had 50,000 or more trucks in their fleets, so they represent a large chunk of the industry. The treatment groups are divided up by size, so we've got 1 truck, 2 to 6 trucks, 7 to 20 trucks, and so on. And the idea is that as we go into smaller size bins, they're less and less likely to have been using ELDs prior to the mandate. Now, it's important to note here that some carriers in each of these bins were certainly using ELDs before the mandate went into effect. Definitely not a clean treatment group. But if there are carriers in these bins who were already using ELDs, it would bias the estimates of our causal effect downward. So it's a more conservative estimate than it would be otherwise. So this table just kind of describes the data a bit. We've got our size categories here on the left. We've got number of carriers in each of those categories, as well as the inspections, violation, and crashes in each of the 3 periods under analysis. A problem here is that even though we observe a lot of events, a lot of inspections, lots of violations, lots of crashes, the probability of any particular carrier experiencing one of those events is quite low, particularly for the small guys, right? Because if you're running 1 or 2 trucks over this, however long this period, I think it's 87 weeks, you're probably not having a crash. You're probably not having an hours of service violation. And so to get around that issue, the authors aggregate by cohort. So each observation in the analysis is one of these cohorts in a week, all aggregated together. So we go from our sample size of almost 250,000 to a sample size of 7, just kind of piling them together. But they observe each of these cohorts over the full 87-week period, and so they calculate each thing within a week. So we end up with roughly about 609 unique observations. So before we get into the way they go about testing this, we should really talk about the three outcomes they're interested in. First, we've got the hours of service violation rate. So it's the number of hours of service violations divided by total inspections. So to get one of these violations, you have to be inspected. A law enforcement officer has to look at your log. It doesn't happen automatically, even if you've got electronic logs. And so these would include driving over your hour limit, failing to take required breaks, having fake logs, or having no record of duty status at all. The next outcome is unsafe driving, and that's just the count of unsafe driving violations. And in the model, they take the log of it just to meet some model assumptions about the distribution of the outcome variable. And these include speeding, failing to obey traffic signals, falling too close, or improper lane changes. Basically stuff that a law enforcement officer might pull a trucker over for. And lastly, we've got crashes. And so it's just the count of reportable crashes. And for DOT, a crash is reportable if it results in a fatality, an injury, or a vehicle having to be towed away. So these are the three outcomes that the authors are interested in. And the way they go about this is using something called a difference in difference regression model. And difference in difference isn't so much a type of regression as it is a way of specifying a regression that lets us estimate causal effects if we've got longitudinal data and some external source of variation, right? In this case, we've got a policy change. And so in this equation here, the outcome variable, y sub it, is one of those three outcomes we just mentioned, but for the size cohort I in the time period t in our 87 weeks. They control for fixed effects for both the cohort and the week with the gamma sub I and the lambda sub t there. So that's going to help us control for time invariant confounding that occurs at the cohort level and confounding that happens over time but affects all cohorts equally. That does leave the whole of time variant things that affect each cohort specifically, but it's pretty common practice in this literature to do it that way. There's also a vector of control variables on the far end there. I'm not going to spend too much time on that, but what we're mostly interested in here is the delta and the beta. So the idea is that excluding our control group, we've got a variable for each size cohort, just indicator variables, and we interact those with D1, which is the light enforcement period. So for every observation in the data set, if that time period was in the light enforcement period, D1's a 1, and if it wasn't, it's a 0. And so by interacting the size cohort with that treatment variable, we can see what the influence of the ELD mandate was for each of those size cohorts in the soft enforcement period. And likewise, we do the same thing with D2, which is the indicator variable for the strict enforcement period. And so our deltas will give us the impact of the light enforcement, betas will give us our impact of the strict enforcement. Now, for that model that I just showed to be interpreted causally, you need a number of assumptions to be met. And this is why these papers get so long. You get a few numbers, and then you have to build a fortress that is going to say that I meet all these assumptions. And there's a pile of graphs and tests and explanations. But really, like when it comes down to it, the parallel trends assumption is the most important assumption. And this assumption is really what makes this kind of paper sink or swim. And the idea is that in the absence of the treatment effect of the treatment occurring, the treated group's trend in the outcome should have remained parallel to the control group's trend. Now that's a mouthful, so let's do it visually. I love a graph. So here we've got a graph where we've got some outcome on the vertical axis, time here, there's a pre-treatment period, post-treatment period. Green line represents our control group, red line represents our treatment group. And so the idea is if we imagine that this intervention didn't occur, our treatment group's trend doesn't have to lie on the same level as the control group, but it has to parallel the control group. So this dotted line that we don't actually get to observe has to have tracked parallel with that. Now, as I said, this is the most critical assumption of these types of models. Problem is we live in a universe where the intervention did happen. So we can't see anything on that dotted line. So it means that the linchpin assumption of these types of papers is essentially completely untestable. Now, what we do to kind of deal with that is we say, well, we can't test if the dotted red line and this green line were parallel after the treatment. But we do see both groups untreated prior to the intervention. So let's test if these were parallel. And so that's generally the way that in DID papers, people try to argue that they meet the parallel trends assumption. So let's look at some squiggles. So on the left here, we've got the hours of service violation rate. So that's that first outcome variable. And on the right, we've got crashes, which is the last outcome variable they're interested in. Each line here represents one of the size cohorts, and it's just charted over the 87-week period. We've got the different treatment periods kind of shaded in there. Now, looking at the hours of service violation rate, this is probably about as close as like textbook parallel trends that you'll see, right? Like we've got our control group, it's pretty flat, and so are these. Like there's some downward inflection, kind of maybe anticipating the mandate, but if you squint, you can kind of see that even in the control group. Crashes, on the other hand, whole other story. Our control group, which is that darkest line at the bottom, has this U shape to it that isn't present in any of the other treatment groups. So now you might hope that there would be a better way of assessing this assumption than just looking at the squiggles and saying, yeah, that's about right. And there is. So they do some formal regression analysis that is trying to bolster their argument that the parallel trends assumption is met before the intervention. And they generally conclude that for the hours of service violation rate and the unsafe driving count, which isn't pictured here, that for both of those, the parallel trends assumption is probably met. For crashes, less so. So they lack so much evidence for crashes. So they kind of color their interpretations of the crash data as being, maybe don't interpret this as causal. So after all of that buildup, we finally get to the headline table of the paper. So here we've got the deltas, which are the treatment effects for the light enforcement period. And we've got that for hours of service, log of unsafe driving, log of crashes. So in this first column here, these are all negative and significant. So what that means is that compared to the control group of those large carriers who were using ELDs prior to the mandate, all of these smaller cohorts saw a significant reduction in hours of service violations following the beginning of the soft enforcement period. To put that a little more concretely, so for instance, the cohort that had a single truck saw a 0.027% reduction in the number of hours of service violations relative to the number of inspections. Now that sounds really, really small, but it's also important to remember that on average, each violation really doesn't include, or each, speaking too quickly. Most inspections do not result in an hours of service violation. It's actually a quite rare occurrence in the data. So even that kind of small effect is a big effect proportionally. We also see a significant and positive coefficients for the unsafe driving model. So this would suggest that even in the light enforcement period, we saw a reduction in hours of service violations, but an increase in unsafe driving. The interpretation is a little bit different here because it's just a log transformed count. But again, kind of just interpreting the one truck model or the one truck cohort, there was about a 13.5% increase in unsafe driving violations, which is a pretty significant increase in the count in terms of practical impact. And then finally, in the crashes during the light enforcement period, There's not so much significance only for the one truck case, and it's actually a reduction in crashes, which the authors don't spend much time talking about. This is the same table, just a little further down. And now we've got the betas, which are the treatment effects for the strict enforcement period. And kind of second verse, same as the first. The hours of service violation rates are falling, but they're a bit larger. The unsafe driving is increased as in the previous for most of the smaller cohorts. But now there's some significance in the crash side of things. So there's all of the size cohorts have a significant increase in the number of crashes relative to the control group during the strict enforcement period. And these are, again, kind of pretty practically significant practically significant impacts. So for 7 to 20 trucks, which is the largest treatment effect here, we see almost a 20% increase in crashes, which is kind of startling. So just to kind of sum it up, the authors have pretty good evidence that the ELD mandate resulted in fewer hours of service violations. Pretty good evidence that unsafe driving violations went up. So for their core argument that there's some offense displacement going on, I think that evidence is fairly convincing. For the crashes, they're able to show these kind of positive treatment effects, but given that they violate some of the model assumptions, that's got a bit of an asterisk next to it. And finally, they argue that when regulators implement this sort of kind of surveillance scheme, they should be really concerned about unintended consequences, particularly when you've got a lot of rules that interact with each other, right? Like speed limits are interacting with hours of service, which are interacting with, all other kind of rules of the road. So I thought about doing the whole advantages and limitations sort of slide here, but I think it might be more fun to just start with, do you buy it? Hands up, anybody who doesn't buy it. I thought it would be you.
That's because I go off on all the papers about all the problems they have. I only sort of buy it because of all the issues that thankfully they seem to acknowledge several of them, and you pointed out some additional ones. And so I think to really be confident, you got to have a randomized controlled trial, right? And that's not what this is, right? And so I see more associations than I see any causal claims that could be made, right? Which is fine. And don't get me wrong. I actually see this one as having a contribution. But I wouldn't bet the farm on it,
So do you think regulators should take this conclusion seriously?
Not by itself, no.
Okay.
I wouldn't, because it's going to be very costly to implement, and if you're wrong, then they're very cost conscious, which may or may not be the right thing when you're talking about people and safety and stuff like that. Sometimes it's okay to spend more money to take care of people. In fact, most of the time it is okay to spend a little more money on that, but I don't think you're going to be able. I don't think this. If they're aware of science and practice and how that should operate, they're not probably going to be convinced by this.
A couple of reflections sort of related. I think the effect of the electronic logs on hours of service violations is super clear. And time series experiments and natural experiments can be pretty powerful in demonstrating that if data are stable, if trends are headed in the right direction, and that one figure where the violations are all being driven down.
It's hard to argue with that.
It's hard to argue that policy had an effect on that outcome. As for crashes, I think hours of service violations are probably most strongly related to fatigue-related crashes. So I think there may be a different pattern in crash findings. If you look at the subset of crashes that are single driver, nighttime, or not involving any other vehicles, all of the sort of indicators of fatigue-related crashes. But super fascinating hypothesis that that you're gonna push on this side and then bad behavior squishes out over there.
And I mean, just kind of two responses to that. One is somebody who's been elbow deep in these data sets. You know, there's reliability issues, which happens in any administrative data set, but you could easily sort out the crashes that have other vehicles involved versus ones that are single driver sort of stuff. So it would be completely possible to replicate this for that subset of crashes without too much effort. But the other point there escapes me at the moment. So anyway, any other thoughts on the do you buy it point?
This was actually predicted by both truckers in the industry for implementation of the rule, very important. And the regulatory side decided they knew better. And I'm just raising the caution for folks. When you put in place rules, vet them widely and do listen to the critiques. And there is a large cost that was associated with implementation of this rule, and we're all paying it right now. And it does raise questions about what is the best way to approach this. So the truckers are like, not everybody sleeps on the schedule, you know, and you start mandating time off and stuff like that, and then people are, you know, screwing around with the time, and there's all kinds of wild stuff that starts happening. They predicted it all. And it's just fascinating to see the data say, oh, they were right.
Yeah, and I mean, like Michael Belzer, who we had here last year, he talks a lot about how the electronic logs are seemingly infallible, but it can just tell if the truck's moving. It doesn't know what the driver's doing. And so there's a lot of kind of shifting of off-duty, on-duty logging, and whether you're in your sleeper berth or you're not, that is still kind of chiseling around these requirements. But also you see a lot of kind of FMCSA listening to a lot of criticism on the hours of service requirements after the ELD mandate. Like there's been pilot, I forget the specifics of them, but there's been some pilots on adding more flexible rest times and things like that. And I think they're allowed to split rest periods now that
Driving teams, yes, that was a pilot. And we have seen logbooks for team drivers. And if you're a team,
oh God.
There's no way for the e-log to really be sure who's driving and who's not. And they're actually in the highest need for flexibility because of shift worker sleep disorder, where you can't really stay asleep longer than 4 or 5 hours because you're trying to sleep in the day and your body clock is dialed in to have you sleep at night.
I guess I'll hand over here.
Yeah, I was just gonna say that when I was working in like a manufacturing plant, I saw something really similar with the like clocking in and clocking out and stuff. Because they were requiring you to break for 30 minutes for lunch. And a lot of the people who worked on the floor were like, we don't need 30 minutes for lunch. Like, this is silly. But so they would just like clock out and sit there for 30 minutes, and they were all up in a huff about it. So I'm not surprised that people were getting really mad about it here.
So I think, yeah, I mean, truckers are like culturally fiercely independent. Like a good story that that I very much enjoy is whenever ELD started first coming out before they were mandated, a lot of these ELD manufacturers would have a sticker you could put on your truck saying like ELD equipped. And this became a signal to inspectors of, oh, they have an ELD. I'm not going to inspect that truck, wave them through. And so then there came to be this entire secondary market of these stickers where particularly owner operators who run their own trucks and are very unlikely to be using ELDs would buy those stickers on eBay, slap them on their trucks so they'd get waved through the inspection station more often. So we don't have much, we don't have any time left, but I'm going to squeeze in one more at the end because this is what's most interesting to me is what variables should trucking safety regulations actually be targeting, right? Is ultimately all we care about crashes in terms of kind of a highway safety perspective, or should we be thinking about unsafe driving? But this seems like a very clear example of the regulators were targeting hours of service violations, which might not be the best approach in terms of the outcomes we might actually care about.
Hours of service also includes not a lot of consideration for, but it should consider worker health. So crashes are a worker risk, but the risk of a fatality is like 9 times greater if the large truck's involved. But hours of service allow a person to work right up to the limits of human capability to stay vigilant in a truck. But there was an element of the rules that have been in place since 2013 that to get people on a 24-hour clock. So circadian rhythms were meant to inform the rules, but I would say worker health should be considered in addition to crash risk, and they're associated.
Mhm. Any other thoughts?
So there's a classic article that I often talk about with my students in OHP. It's on the folly of rewarding A while hoping for B. Has anyone ever seen that? Anyway, it's a classic article. We often assign it, but which is the idea that you are rewarding one behavior and hoping that this other thing happens, and when it doesn't, you're like, why didn't that happen? And what we talk about is how in manufacturing you reward the lack of injury, but what actually gets done is a lack of reporting, right? And so there's a whole bunch of bad behaviors that got inserted, started happening when ELD were implemented. Like, oh, we'll just buy a sticker, right? And now I'm not going to get inspected. That wasn't a behavior that was done before the ELD system was put in there. There wasn't a way to kind of circumvent the inspection process by having that on there, you know? So whenever we think about what we're going to do in terms of the outcome variables, we need to think about what are the unintended consequences that might happen if we require this or if we do this thing, and keep an eye out for those things as well, because those could be even more problematic than what you're trying to actually change, right? But I agree with Dr. Olson that if you actually are concerned about safety of the worker and the health and well-being of the worker, I want to find out what's the health and well-being of the worker currently and address that. You know, some people actually probably aren't able to physically drive a little further or a little longer than someone else, and someone, you know, and those variability factors aren't taken into consideration with these ELDs, right? But now that we can track human biological functioning, maybe we go that far. I don't know. I mean, there's a lot of possibilities there. So.
Yeah, and I do, as a matter of trade union pride, have to always harp on the fact that this is an incredibly competitive industry where cost pressures are immense. And so both employers and drivers are really just kind of pushing right up to legal limits whenever they can. It's less of a limit and more of a target in a lot of cases. So
I don't know if I'm allowed to talk, but I'm going to. I'm Mitch from Mortensen. We're going to present here in a little bit, but you know, this is interesting. It's not just in the trucking industry or manufacturing, but you know, regulators try to fix people instead of fixing the things that drive bad behavior, kind of like you were just talking about, right? So instead of, you know, putting more regulations on the people, try to disincentivize the bad behavior. Why is it such a highly competitive market? Like, how do we fix that? Instead of like driving per load, you know, I get paid per delivery, like figure out how to change the system rather than changing people, because people are people and they're going to only be as safe as they think that they need to be. But if you create a new system for them to operate in, that's how safety is.
But then we're talking about economic regulation, and
Sure.
people get very angry about such things.
Yeah.
But I think I am well over time, so I will close it out there and hand it off. But thanks.
The natural law rate, or is it an act?
So it's the law.
No, it wasn't.
Yeah, yeah. I just realized that. To the Friday before spring break.
I don't like the way you
So,
Because if it was a rain turn, I would be
here because of that, because they're like, well, it's Friday, so I can, you know, have the whole weekend wherever I'm going. It's a lot of fun, whether they go to or not. It's Getting out of here, so.
It's,
So there won't be quite
there's
as
a lot of things that I don't want in that paper.
those that are here will enjoy it. It's very, I think if you're okay with my recorded. Yeah. Sure.
Yeah, thanks for having us.
All right. I can't tell. Is that working?
It's good. Yep.
Right on. Okay. All righty. I picked an article today that I thought would be easy. Turned it into Bubba and then realized that it was harder than I thought it was going to be. So that's good. I asked ChatGPT for an image of the average night shift worker. It gave me that. No, I'm just kidding. I gave very specific instructions to illustrate how I felt about it while I was on nights. I did 2 years of 312, 6 to 6, all night long at Myriad up in Research Park. By the end of that, I started to feel a little bit disconnected from reality, a little bit out there. How many out there? How many have done long-term kind of night shift work, more than just a few shifts, off and on, maybe when you were younger? It's more common than you'd expect. Up to 20% of U.S. workers are on nights or regular shift, which we'll learn the difference of and where they overlap here in a minute. Yeah, this one is Mary Davis. With some background on the topic, we know generally regular shift work is bad news. There's been a multitude of studies done already on that strongly link it to different health effects and mental health effects and work-life problems. Like I said, it's much more common than you expect. I expected more hands when I asked how many people have done it before. But it's been linked to some serious stuff, between seemingly unrelated things like diabetes and heart disease to the more obvious maybe effects of disturbed sleep and insomnia and poor sleep quality, which I can definitely attest to, all the blackout curtains that I went through. One experience when I was still on nights in the thick of it, I was invited on a trip down to Moab and had zero fun. At one point they had some music on and they were enjoying some food, and I was dead asleep in the middle of the living room with people. I was laid out on the couch and people were sitting all around me just having a blast, and I just slept through it. And needless to say, I was not invited back after that. Like I said, and like we've kind of from the previous slide, there's been a large body of work already done on this, and they refer back to those studies several times throughout in their paper. And then what they wanted to do here was to kind of differentiate between true night shift and the irregular shifts, everything in between, and especially the alternating nights to days over and over again, which my stepfather did for years and really suffered as a consequence. Yeah, they cite close to 20 articles from all around the world of different effects that they've studied, more specifically than what we'll see here. The data they draw is from the National Longitudinal Survey of Youth, 1979, which is a large cohort study of workers born between 57 and 64. Interestingly, the workers born in 64 were 15 years old in 1979, and they were working night shift. So some definitions for the reading here. Shift work is anything that is outside of the standard 9 to 5 workday routine. So you've got both your night shift and your regular in there. Then the irregular shifts are these answers. The question they were asked was, which of the following categories best describes the hours you work at this job? And then the answers that pertain to their definition of a regular shift is shift rotate, split shift, or irregular schedule or hours. And then they were combined in a general shift term in the data. And that included especially the rotating day and night shifts, which have got to be the worst schedule. And then the health limitation, which will come in, will be very important to us later, is a self-reported health condition that limits their work activities. So here they gave us some statistics to look at. 13% of answers were pure night shift as their primary job, and that increases as they include any job, part-time and secondary and such. And then irregular shifts were 12%. And then that general shift, which just includes a couple categories, is up to 21%. Their statistical model was a random effects logit model, which I had not heard of before, and still don't fully understand, but it produced some easily readable odds ratios, which was helpful. So over 6,000 individuals responded to this 20-year observation follow-up period between 94 and 2014. And it gave them a sample, what seems like a solid sample size of 52,500. 15% of them reported a health limitation. And then we can kind of look at here in these tables. These are snippets of the tables. There's some interesting but unsurprising protective and risky behaviors also in the full tables 2 and 3, such as exercise and health insurance and such. But here, what the first interesting result to me was that night shift by itself only had a statistically significant harmful odds ratio when it was considered cumulatively longer term over years. And even that odds ratio is fairly weak at 1.06 versus that you can see there in table 3 that the odds ratio for just shorter term irregular shift is much higher at 1.52. So in their discussion, they laid out their results fairly clearly for us that shift work does increase the likelihood of health limitations. And they, like I said, night shift is only statistically significant in the cumulative category. The other two, how do you go back, Bubba? Which button?
Top button.
Top button.
Yep.
There we go. You can see those 1 and 2 under night shift, that bottom end of their confidence interval is below 1, making them not statistically significant for the harmful odds ratio. So that's, and then their largest effect was from that irregular shift work as a primary job. And their discussion of their results is fairly brief, and then they refer back again to the other studies that had been done with specific results. They referred back to spillover benefits for businesses, which they mentioned increased productivity, increased revenue for businesses with stable daytime scheduling. And they referred to other studies out of Europe that had much more strongly linked shift work with chronic fatigue, metabolic syndromes, and insomnia. And I think that they may have referred back to those other studies again, maybe to provoke some interest in drilling down to whether night shift is associated with these strongly, or if it's shift work in general, or if it's those irregular shifts that are the most harmful for those health effects. For the AI portion, I asked ChatGPT to summarize this article so that I could compare what it had to say to what I could just read on my own from the just glean on my own from the reading. And it seemed to be pretty accurate and easy to read in its interpretation. And it seemed helpful for me. I know we've discussed in the past the limitations of AI and the BS that it'll put out on kind of a large scale search engine level. So I wanted to kind of experiment with, if I give it just this piece of information, what can it pull out for me? I don't need you to go search the entire internet for what's up with shift work, but tell me what this article itself says about it. So that was encouraging to me for a proper use of AI chatbots and the like. Some strengths, I thought the sample size seemed large. I don't have all of the sample size restrictions and requirements, best practices memorized for different types of studies, but 50,500 seemed like a decent number to me. Their statistical methods seemed pretty solid, and I did pass Dr. Zhao's class last semester, so that was good. And then the background literature from previous studies seemed pretty well established, and it was interesting to me. I got sidebar. I went off on tangents, actually looking more at the other studies than I did at this one. They were very interesting. The weaknesses that I could find were actually lined up perfectly with the limitations that they mentioned themselves. That is that their data is limited to the 20 years of follow-up from 94 to 2014. And the data from 79, data from the more recent years is not there. Even some of that follow-up is missing for some of the workers. And then the biggest one that from the beginning to the end, I was like, what? And they also mentioned is that health limitation, that term is far too broad a category. It is subjective and self-reported, and it's nearly impossible to determine any sort of causality from shift work to health limitation. What does that even mean? Yeah, here's some discussion questions for us.
Can I zoom in on your last question there?
Yeah.
And this is more kind of an open to the floor question.
Yeah.
Does the existing kind of shift work research show that different people are affected in different ways, or are the effects pretty like homogeneous across individuals?
They are pretty consistent. I mean, there's individuals in everything. So, yeah, there are a few people out there absolutely love the night shift, and for whatever reason are perfectly healthy with that. Even with the natural circadian rhythms of human bodies, there's always the unicorns out there. But in general, shift work is pretty terrible for most people.
A lot of people, though, when you're in a plant and you're actually taking care of that population that has third shift, there's a lot of people on third shift and they love it. So I would say, I would actually argue it's not a unicorn. And these people love it for reasons like they'll go skiing in the day and they love it because they can go during the week and they don't have to go to Costco on Saturday. I mean, there's all kinds of reasons like that, but I don't know, are there that many studies though that test Kevin's point though of this issue? Cause I've seen a few things coming out about the night owls and they really are different than the morning.
I'm not sure about if there are studies specifically about that particular type of individual. Do you know, Brian?
Not a longitudinal type
Yeah.
epi study, but I haven't looked for it.
I haven't either.
I've
Just not
talked
general.
with Andrew McKill about, he has an interest in studying shift work selection based on, or assigning shifts based on your orientation, night
Yeah.
owl or lark. I am aware, I haven't read the paper, but I was told about an OHSU nurses study of night shift nurses studying their circadian rhythms, and there is a proportion of the nurses who never adapted biologically to the night shift and others that did. So there's probably individual differences in speed and efficiency and your circadian rhythm moving or adjusting, but even with that, it's very hard to adapt your biological clock to the night shift because it requires so much control of light exposure and eating behaviors and on and on and on. For me, while I've got the mic, I'll just say that the standout finding is irregular shift work is worse than night shift. Understanding the outcome has its limitations. And that jives with some of our findings with bus operators that irregular shift work seems to be more health disruptive. And that degree of predictability, and you're the third shift person, you prefer it, you can plan and predict and design your life, but irregular shifts are going to be more behaviorally disruptive.
Yeah, like I mentioned, my stepfather had done the rotating 3 on 3 off nights to days every rotation, and my mom had a full year's calendar laid out with specifically which days he's on days, which days he's on nights, and that's how we would have to plan family events around that work schedule, and it's extremely difficult.
Thank goodness we have some police willing to work Saturday nights. Can you backtrack to one of the people have the article? It's on page 268.
I don't have table 4 in here.
Okay. That's okay. If you look at table 4 though, and you may remember this, and you've had a lot of things with statistics, and some of them are pretty striking, really. If you look at that, you got, well, first of all, why are men protected as much as they are?
Yeah.
And then you've got multiple health wellness type things. Exercise, diet, smoking are pretty strongly related.
Yeah.
Yep.
And diet isn't exactly diet. It's you tried to lose weight, so it's probably a marker for BMI.
So if you look at that sort of stuff, that really gets into the confounding question, which by the way, the table, if you notice what it says at the bottom, I can't even tell that. I assume it is, but I don't know. I looked in the text and it's not there either. I was like, wow, how did that slip through peer review? But the point being, when you have that strong a relationship going on, you want to rule out confounding. And the other part of that is, even if you have in the model, when you have that strong set of factors going on, residual confounding is pretty much guaranteed.
And to that point, I was kind of shocked they did random effects, because this seems like, unless there's a lot of attrition in the data, which admittedly I did not read this deeply because I had to present today, but if there's not a lot of attrition in the data, this is like a textbook example for two-way fixed effects, which would get rid of a lot of unobserved confounding and give me at least a lot more confidence that they're showing some sort of causal association.
Might answer your second question there. I've had the opportunity to try to implement fatigue management programs around the world, right? There's all kinds of things out there today. There's caps you can put on that monitor fatigue. There's glasses you can put on. There's instruments at Caterpillar and big equipment manufacturers have to monitor fatigue the whole bit, all kinds of different science. And we used to also not only, we would train families. I was laughing when you were talking about your blackout curtains, right? We would even teach the families, even your mom's schedule and the whole bit, and, you know, how to help your spouse or whatever your partner during night shift. And
Yeah.
so we did all of that. And I think the results were kind of, I mean, they were right on and they were very good. We found that one of our biggest issues where we knew that you're on night shift, 3 o'clock in the morning, you're wearing this cap, feels that you're going into micro sleeps, that one of the most effective things that we could do to help you was put you in a room, in a blackout room, and allow you to take a power nap. You know, and that had a great impact. The issue was that the companies were not going to let somebody sleep on the job. That is like, you know,
Taboo.
we actually found
Yeah.
companies in industries to try to sleep, particularly in the US, it's just not acceptable. You know, you've always heard the story about, you know, if you ever got caught sleeping, just make the sign across, you were okay, right? So, that was a standing joke, you know. But anyway, that's what we found. Not necessarily realizing the signs or how you can intervene or the interventions.
Don't even let cashiers have chairs. Like,
And then we haven't been on the issue.
Yeah, I'm 6'5", and I've been in labs since I graduated undergrad, and in every lab I've had to beg for a stool because all the benches are down here, and so I'm doing this on the bench, and it's been a struggle to get a simple stool for me to roll around in the lab. But yeah, we did. I took quite a few naps on the job at Myriad while I was on nights.
So, you know, the unicorn thing, I was, you know, with what Kurt was saying was that when I was in my early 20s, and I should have raised my hand when you said shift work, I worked straight night shift, not irregular, but straight night shift. And I loved it in my early 20s. Today,
I loved it for the first year. Yep, for the first year it was fine.
Mm-hmm.
Yep, and that matches up with what they're saying is that you know, your primary job, night shift, it doesn't seem to be harmful, but then cumulatively over time, it gets worse and worse for you for straight night shift.
And I wonder to what degree the exposure as a 20-year-old affects you later on. Because we talk about, I mean, the reason I'm thinking about that is because I've been thinking a lot about the Fight or Fire Cancer Initiative, and it's the exposures during the early days of the firefighter's career that sometime later leads to cancers that typical non-firefighters don't usually get, right? I'm not saying that this is the same kind of exposure situation, but I wonder to what degree.
in my situation, I gave you white hair.
Yeah. See, look at that outcome.
But you're right.
Yeah.
I think on your second last point, the most important things, I know we're out of time, otherwise it's just quizzing people, but it's really quantifications, you know, and including even the last bullet, because I'm of the opinion, I think you're right, there are differences between the night owls and the morning lark issues. I think we just haven't studied it. We're talking about now that there are people who love that stuff, people who, I mean, they crash your car on the way home, they drive to you outside the plants.
Yeah, when they say they also have maybe another confounder, I'm not sure. When we talk about pure night shift versus irregular, I was on 12s from 6 to 6, right? But there are, you know, the 3-shift setups where you have your, you know, 6 to 2 and 2 to 10 and 10 to 6, right? And which of those is going to be more harmful than the others? And you know, is 12 to 12 the worst, or are there better setups that are still night shifts?
Like randomizing that, the union balk at that.
Maybe this is one of these intuitive things we don't need studies to know. We can know that this is bad. We don't need studies, but
really quickly in the last minute here on your first question. The experts and everyone involved in AI and all the rich and folks say that artificial general intelligence, which essentially is artificial intelligence that has the cognitive abilities equal to or exceeding human beings. It's still like 2, 3, 4 years away. And then it's only going to go exponentially beyond that very quickly. So like in a couple of years, we're going to be looking at that question, which is totally reasonable and looking at like, oh, like, what a silly thing to even think that it would not be capable of that. It's not be capable of this type of thing beyond what we can even sort of understand.
Yeah, when it drew me that picture, and I'd never had AI generate an image for me before, and I saw that little circle go around in less than 10 seconds, and it's shocking interacting with them anyways. But I expected some nasty picture with messed up hands and stuff, and it was pristine. It's perfect. The progress that's gone over in the last year is astounding.